Okay, so let's take a look at when we are trying to do a simple linear regression in SPSS. Typically, you wouldn't want to do this kind of analysis in Excel because it's a higher level statistical inferencing technique. But it's basically when you're trying to compare, you know, um, you're trying to look for an association and you want a little bit more of a stronger assumption. We saw the list of assumptions um, in our lab slides, as well as when you are looking at a continuous outcome, right? The continuous outcome in this case is blood sugar. So let's learn how we can do that in SPSS. And it's pretty simple. All you go to is analyze, right? And we're going to be doing a regression. So you want to go down to the regression tab, and we're going to be doing a linear regression, right? There's many different other types of regressions you could do. Like this is the logistic one that I was telling you about. Logistic could be a binary logistic, meaning, right? Like when we saw bivariate, when we looked at this correlate, we just know that meant that it was only two variables, age and blood pressure. With regression, if it's a binary logistic regression, that means that your outcome is just that yes or no, hospitalized or not, insured or not, et cetera, et cetera. Multinomial logistic regression is when you have multiple variables and you're trying to make a prediction. So we're not going into any of these like ordinal, we're not going into these types of regression in this class. These are like higher level stuff. We're just going to look at simple linear regression to start. And if you want to try some of these, or if you have any other additional questions about it, you're welcome to reach out to me and let me know. I'm pretty sure if you take a higher level statistics class, though, you're going to go into those things. So we're going to do a simple linear regression. And again, as I explained in the lab slides, you want to have your dependent variable, right? What is the dependent? Well, that's going to be your outcome, right? And the way I told you guys, I remember it is the dependent variable is always dependent on the independent variable. So your dependent is going to be your outcome variable because it's dependent on what happens with your predictor. So this is going to be our dependent variable, the outcome. Our continuous outcome is going to be blood sugar. And age is going to be our independent variable. So we want to put that in this bracket here. And let's see what statistics are available to us. Yeah, that should be fine. We don't want any of these things. We just want the model fit and the estimates. That's okay. You can also get the 95% confidence interval, but we're not going to look at that in this case right now. But you can get it, and you can add a plot if you want to it. But we're not gonna add a histogram plot or anything like that right now. You can actually do the scatter plot within your regression, like if you want all the output to have that in one. But right now, what I want you guys to pay attention is to the Save tab right here. Click on that. And then it gives you more options for what your output could have in terms of your regression. So what we would like is the residuals, right? We want the R. Let's see, we get the unstandardized, standardized, influence statistics. So we're going to get this data on prediction models, individuals. Yeah, we don't really need, I don't believe any of this other stuff. So right now, let's see what happens if we just get the R, the residuals. Okay, so click continue. And let's see what happens when we hit OK. Let's look at our results. Yes, so this is what I wanted. So here's the variables that are entered. When we look at our regression, we have this model, right? Our predictor is age, and we have a continuous outcome. So these are the variables that are entered. If you have more variables entered, then you can do, it'll have others, like if you want to say age, if you want to look for race, whatever the case is. But for right now, we're just looking at one. We're doing a bivariate simple linear regression. And then the next table we get is a model summary. So the model summary is nice because it gives us the R, right? It tells us how correlated our two variables are. It gives us the R squared value, and it gives us the adjusted R squared. What we really want to pay attention to here is, most importantly, right, is the R, because the R tells us how correlated the two variables are for when we look at the regression results. You also get an ANOVA table, which shouldn't surprise you, because we are comparing, these two groups to each other, and we do have that significance level. That significance level that we saw with the correlation value before is basically the significance level of our F statistic, and that is determining, whether this is statistically significant or are not. In our case, it is. So we get an ANOVA table, we get the sum of squares, right? And degrees of freedom. This is not really, if you want more information about these things, you can go into that yourself. But what's important from the ANOVA table is that we're getting the significance level of our correlation value. We also get F statistic. F statistic is also pretty high, which is a good thing. One high F statistic, as you recall from our ANOVA lesson. And then the last two important parts of your output is, okay, so no, we actually didn't need this residual statistic. If you don't want to click on this, you don't have to. We're not going into depth on this. But this is what was important. So I didn't need to click on those residuals, actually. Let me stop here. It tells you here your dependent variable is blood sugar, and we are getting coefficients here. So these coefficients represent the beta estimates. When we looked at those formulas with the y, right, our y is our continuous outcome, beta 1, plus, beta 0 times beta 1 times x plus the error term, right? This is the result that measures our beta value. And beta, as I told you guys from our interpretation, is telling you sort of what the trend is that we're seeing. It quantifies the trend that we're seeing in that correlation overall. So the first row we see is a constant. The constant is just telling you what the value of your beta will be if all your values were held at 0. So this is not really what's important about this output. What's important about this output is the age. That's what we're interested in. We're interested in age as our predictor and how it interacts with our outcome. So our unstandardized beta for age is 1.762. This is the value that you want to report when you're doing your results and you're summing up your research or you're summing up your analysis. You want to report this beta, the unstandardized beta. Then you have, a standard error, which is also, something you want to report as well because it tells you a little bit about age in this data set. But again, then you get the standardized beta coefficient, right? Standardized coefficient of beta, as you can see here, is the same as the correlation coefficient. Then you also have a t-test that's done because we have a small sample size, right? So we're going to do a little t-test, and then we're going to have our significance level for that t as well. Okay, so what's important here is to interpret this. When you want to interpret what this beta estimate means, which is the most important value in this table right now, this is basically telling you more about the slope, right? So for every unit increase in your predictor, your outcome increases by this much. I'm going to reinterpret that. For every year older that you are in age, your blood sugar increases by 1.762. That is what this is basically telling you here. And what I'd like to do is, let me actually write that out for you guys so it can hopefully help it stick. Okay, so I'm going to share this screen. Okay. So let's get down to let's nail it down to what our results are right now. We're going to interpret this. Okay. All right, so you should be able to see my screen. And so again, beta estimate. Oh, here we go. So that beta that gave us the value of 1.762. What it basically means is, so we have a beta of 1.762. you know, we know that our x is equal to h, right? Sorry, age. It says age and our y value is equal to our outcome value, right? Is equal to blood sugar. All right. This is going to say blood sugar. Sorry that this is so terrible. But I had to redo this, and my iPad's now dead. So basically, what we're doing is we're looking at the relationship of age on blood sugar, right? That's what this is here. Okay, so how do we interpret this? This is how we interpret our beta coefficient, right? The beta that we got from our regression analysis. We say, okay, I'm getting a little cut off here. Hold on. Let me fix this. Sure, there's a space. Looks good. Okay. There we go. This is a little better. Okay. Boom. So let's interpret this beta coefficient. This is basically saying for every year, because this is a slope we're interpreting, right? For every year older you are, in age, comma, that says age, comma, your blood sugar blood. Right, I'm gonna just call it BS. Right, make it a little easier on myself. It's gonna be BS, and this abbreviation only stands for BS, blood sugar. Okay, not anything else. For every year older you are in age, your BS increases, right? Because we're looking at our outcome here. By, I wonder if this is even showing here. Yeah, for every year older you are in age, your BS increases by 1.762. That's how we interpret the results of our beta estimate when we're looking at a simple linear regression model. Okay, and again, if you wanted to get more information about how we could do logistic regression models when our y, right, when our y is not, like, so this one in this case, obviously, y is continuous, right? Blood sugar is measured and on a continuous scale. But if we had like a proportion, like blood sugar yes or no, continuous, well then that would require a different analysis, right? If say y was, and this would be, we're not going to go into too much depth into this, but I'll introduce you a little bit just so you have an idea, and if someone asks you, you know what this is. Logistic. We're not going to do this in SPSS, but if you want to do a logistic regression, analysis. Right, so this one is known as the simple linear, the linear regression. Don't forget, this one's linear, and we know that it's linear because our y value is continuous. The simple linear regression. This one's simple because we're only using one x, but you can have multiple. You can have x1, x2, x3, race, age, gender. You know, we're not going to do that now, though. It's very interesting stuff. So this is linear regression, but if you want to do logistic, we would assume that our y is going to be a proportion. It's no longer going to be continuous. It's going to be like blood sugar. Either you have it or you don't. I mean, blood sugar. High blood sugar, let's say. Let's say high blood sugar. Ah. Okay. It'll be like high blood sugar. I'm going to just do high BS. And it'll be like either you do or you don't. And you would run an analysis and check that out. Okay? So I just wanted to give you that little quick heads up about regression analyses. They go far a long way. There are many different types. So there are different types based on, as you can see, obviously, the y value. Right? Whether the y is continuous. In this case, the y would be a proportion, right? And this goes on and on and on. We've been looking at continuous versus proportion the whole semester. And when you want to do a logistic, you have y that's proportional. X doesn't matter. It depends on what your outcome is, because we have to make certain assumptions about our data depending on what type of variable or what type of measurement it is. There's also survival regression analysis. That's if your y value is time sensitive, if it's related to a specific point, different time points. That in that case, you want to do what's called a survival regression analysis. We're not going to go into any of these. I'm just letting you know that there's other ones. And if you're interested, I highly recommend just going on YouTube or checking out, some resources online. I can give you a little bit more about, inferential statistic techniques and doing regression analyses, but we won't go into that into this class. It's not very, this is very more higher level stuff. Okay, well, thank you very much for joining this session, and I appreciate you joining and taking your time to spend with me. So I hope you enjoy.